Hello and welcome to the Poisons and Pestilence podcast, episode 2, Hittite me Plaguey one more time. In our first show, we had some joy in tracing the prehistory of poison warfare, pinning our fortunes on poison arrows. Luckily for us, there were experts waiting for us, who had spent way too many late nights thinking about ancient poisons and digging up arrowheads. We found no smoking arrow that categorically proved ancient use of poison projectiles as part of warfare, but the circumstantial case seemed pretty strong. In today's episode, we're going to attempt the same type of detective work into infectious diseases, something which is quite a bit harder than dealing with arrowheads, mainly because human tissue is so soft. With poison arrows, the poison had usually long disappeared, but at least we had the potential delivery system to look at for clues. With weapons involving infectious disease, this is going to be nowhere near as straightforward. Luckily for us, there are relevant specialists who might help us understand if the idea of prehistoric germ warfare makes any more sense than Microsoft Internet Explorer's conviction that it could, one day, become your default internet browser. We are going to start by taking a look at health and disease in the prehistoric world. This then will involve familiarising ourselves with the witchcraft of two pretty awesome fields, paleopathology and paleomicrobiology. Here then we get a sense of the types of disease folk were dealing with back in the day. After this, we turn towards trying to identify the earliest evidence of biological warfare. It is at this point, it is fair to say, that our evidence base becomes a little more delicate, to put it politely. Coming as it does from at best the tiniest fragments of text carved in proto-languages that scholars have worked for centuries to decode, and at worst, in legends written hundreds, if not thousands of years after supposed events, which are often quite mythical beast heavy. By the end of today's show then, we will have familiarised ourselves with the earliest recorded allegations of biological warfare, and the disease that appears to have been involved. And, if mythical beasts are also your thing, worry not, we'll be seeing quite a lot of them in the next episode, in which we continue our march onwards into classical antiquity. I hope you enjoy the show today. As far as bacteria and viruses are concerned, humans are just a new kid on the block, and this thinking ape has been fair game for as long as they have been around. Through time and place, and as geography and organisation of human society has changed, humans have faced a range of pathogen adversaries. Some are still with us, some appear to have had their day. Back in the hunter-gatherer days, infectious disease was probably way down the lists of things to worry about. My brief scan of the literature suggests it's not entirely clear on how different types of illness would have ranked. It is clear that death in childbirth, accidents and wound infections, as well as chronic malnutrition would have been a prominent feature of prehistoric human life. It also seems that teeth have always led to bother in the end. Undoubtedly, humans would have used a range of plants and other strategies developed by trial and error and passed from one generation to the next as part of early medicine. The field of paleopathology is our best hope today of unearthing this long-buried history and relies on a range of methods for the study of prehistoric hunter-gatherers as well as more sedentary communities. Focusing on bones primarily, but also increasingly drawing upon soft materials preserved through natural processes or mummification. This field has provided some breathtaking insights into the life of individuals that walked the earth millennia ago. This includes the telltale signs of psychoactive substances such as cocaine in 3,000-year-old human remains. It also includes a recent study which applied proteomic analysis to the stomach content of a 5,300-year-old ice mummy. From this analysis, they managed to reveal potential gut problems the individual may have suffered from, as well as the makeup of their diet. They could even be confident, after 5 millennia, that the last meal they consumed included cooked or smoked meat that had been spiced for flavour. The study of ancient pathogens, which is of particular interest in today's show, is known as paleomicrobiology, which is a field with a preoccupation with ancient epidemics. Detectives in this field use a wide range of evidence in the practice of their craft. This includes the analysis of ancient texts where they have been available. In addition, scientists have become increasingly adept at analysing DNA from preserved ancient tissue and bone. Work in this area has provided compelling insights into the infectious diseases which plagued humankind in the earlier hunter-gatherer stages, and later as they began to live in larger populations and maintain closer day-to-day contact with an increasing range of domesticated animals, a set of changes which have long been thought to have resulted in the emergence of more deadly infectious human disease. In this episode, and later when we move into the classical era, there are 3 pathogens which are going to play a pivotal role, and so it is worth examining them in a little bit more detail. These are the causative agents behind smallpox, plague, and tularemia. Smallpox is an infectious disease which can be caused by 2 variants of the variola virus. with variola major being the most common and deadly form. The disease usually starts with a high fever, which is followed by a highly contagious rash, which starts on the tongue and in the mouth and spreads to the rest of the body. It is associated with a fatality rate of around 30% when untreated, and leaves survivors with very serious scarring and often results in blindness. The disease is highly infectious, spreading through physical and face-to-face contact, as well as through contact with bedding and clothing. The disease has been with us for a very long time. The historical record of this course gets increasingly sketchy the further back you go. However, recent discussion of a study published in 2020 sheds light on current evidence obtained from prehistoric human remains. This team specialised in conducting analysis of viral genetic material across hundreds of human remains. This allows them to assess the prevalence of diseases at different points in history, to track the emergence of strains of viruses, and even infer the deeper evolutionary history of the strains they find. Based on their work on remains which date back to 15,000 BC, they are pretty sure that the disease was not widespread much before 2000 BC. They simply have not found cases that far back. The history of the disease since the 5th century is one in which trade, slavery and conquest would bring the disease to new shores with devastating human consequences. The disease was thankfully eradicated by a global vaccination program in the 1970s, meaning that it now only exists in 2 high-security reference laboratories in the US and Russia, states which are but scrappy upstarts in the context of the timeline we are working on today. The prospect of someone getting hold of the last stocks of the virus, or recreating the virus in the laboratory, or reanimating strains from the permafrost keeps a few folk up at night. We'll be coming back to smallpox quite a bit in this series. Let's hope it doesn't come back for us in the meantime. Plague is an infectious disease caused by the bacterium Yersinia pestis. The disease can spread via a range of routes. It can be passed from animals to humans via fleas, as well as between humans via close contact with infected people. There are several forms of the disease which tend to reflect where the infection primarily takes hold within the body. The 3 main forms are bubonic, pneumonic, and septicemic. The disease is notorious for deadly epidemics which had profound effects on global history. This includes the epidemic which ravaged Europe, Asia, and Northern Africa in the 14th century, and is estimated to have killed up to 200 million people in just 4 years. For context, it is suggested up to around 40% of the European population died. Today, you can still find evidence of this disease dotted around the European countryside. Paleogenomic studies have traced this disease back to around 7,000 years ago, and have provided some incredible insights into the history of the pathogen. One recent study has reconstructed the genetic profile of a strain of the pathogen which was found in human remains buried some 5,000 years ago in Latvia. Based on this type of analysis, scientists can even infer how infectious or virulent the disease was. Such studies form part of a much broader debate centred on ancient bones and how, when and why increasingly contagious forms of human disease emerged. Today, disease outbreaks are quite straightforward to prevent and control, as we understand transmission routes. It is also a disease which generally responds well to antibiotics. However, there are still several thousand cases of this disease reported globally every year and hundreds of deaths, primarily in poorer rural areas. The final pathogen we're going to profile today is Franciscetella Tularensis, the causative agent of tularemia, a bacterial pathogen that appears to be much older than humans. In human infection, as with plague, a common feature is a very high fever, but the route of infection tends to play a role in how the disease takes hold, leading to different forms of the disease. I've looked for the list of symptoms on the CDC website, and I can save you the details. I will just say that none of the versions of the disease seem particularly appealing, but at least the prognosis is much better than it used to be before the invention of antibiotics. Human infection typically occurs by insect bites in the natural world, as well as through contact with infected animal hosts such as deers, rabbits, and rodents. This disease then has a very long natural history indeed, and it is even implicated in the earliest accusations of biological warfare, claims which continue to emerge out of the swampy edges of recorded history. And this is something we're going to examine now in a little bit more detail. We know that there were some pretty horrific diseases stomping around back in the day, but were any of these diseases used as weapons of warfare in the ancient world? I have to be honest, on the surface level, this seemed a bit of an odd question to me when I started this episode, even though some of the folk I read seemed pretty taken by the prospect. I mean, what most of us would recognise as germ theory doesn't even emerge until the 19th and 20th century, right? And anyway, even if someone had worked out how to purposely spread disease, without concerning themselves too much with how the death magic worked, or how to close Pandora's box, surely this would all be lost to the sands of time. writing stuff down for posterity seems to have been a bit of a premium back then, so even if something did happen, even if we found archaeological evidence of an epidemic, it would be impossible to distinguish between a natural event and an act of warfare anyway, right? And even if we did find recorded claims of what could be understood as biological warfare, should we take them uncritically at face value? If I've learned anything about the history of biological warfare in my own studies, it is that societies have tended to lie about this stuff, to others, and to themselves. So doesn't that all mean there simply isn't that much we could sensibly say on the matter? Well, we still have a good few minutes left in this episode, so I'll leave it for you to decide. First off, it's probably fair to say that understanding of infectious disease, at least in some fundamental senses, goes back a very long way indeed. This makes sense if you think about it. Despite the picture, which often comes to mind, of the European Dark Ages, in which people were lighting Marlon candles, putting on strange hats and sniffing perfume to sneeze off disease, we were still baking with yeast and making beer, long before we understood what was happening at a microbial level. The idea of contagion is also based on type of associative cause and effect type reasoning that is hardwired into human thinking. There is also good evidence that at least some aspects of ancient Roman and Indian societies understood contagion and engaged in what we would recognise today as basic infection control. Indeed, there is even evidence from the Middle East indicating that this type of understanding goes back to at least 1770 BC. There is not too much of a leap then from here to assume that if it was possible to understand what could stop disease spreading, then it was just as straightforward to think about ways in which disease might be spread, at least in principle. As it happens, there are two tantalising archaeological findings which have been discussed in recent years as evidence of acts of biological warfare that occurred as early as 1500 BC. To put that in some context, we're talking about a period where folk over in what is now England had only just added the finishing touches to Stonehenge. This evidence has come to broader public attention after appearing in the Adrian Mayer book I already plugged in the past episode. And, again now, it really is a great weekend read, if, like me, you like that sort of thing. Both these archaeological findings relate to an ancient people who lived in a region which correlates roughly with modern Turkey. Their civilization had a good run by ancient standards, around 600 years or so, during the 2nd millennium BC. This is before it began to break up, with the scattering of people around what is today Syria, Lebanon, and other neighbouring states in the region. We know a fair bit about Hittite culture from the archaeological record, as well as some slightly less reliable but always entertaining references to them in the mythology of the ancient Greeks and other peoples of ancient antiquity. The Hittites had an active artistic and spiritual life, which is reflected in the figures, pottery and monuments which have been unearthed. They also had a written semi-pictorial language, which was typically carved by leaders into stone tablets, quite labour-intensive. Notably, the tablets which have been unearthed in more recent centuries include a contender for the first ever peace treaty recorded in history, dated to around 1275 to 1220 BC, and this was between the Hittites and the ancient Egyptians. Importantly for us, philological specialists have detected evidence of what on the surface level at least appears to be references to biological warfare. The first makes reference to the practice of driving animals, and I quote, at least one woman, infected by epidemics out of the city and into enemy territory. This record dates from around 15 to 1200 BC. The second set of evidence relates to a war between the Hittites and peoples on the border of the neighbouring Egyptian Empire. A study published back in 2007 and much discussed since brought together evidence in the written archaeological records which suggests not only that the chaos brought by war was associated with a series of epidemics, but that both the Hittites and the Azawans who they were fighting both engaged in biological warfare. The preferred delivery mechanism? Rams, encouraged to wander down the road towards the nearest enemy village. Payload? Tularemia. When this article was first released, it kicked up quite a storm, with bioweapon experts at the time not entirely sure what the ramifications, their pun, not mine, of these claims were. While this episode is now commonly cited as a first-known incident of biological warfare, it continues to attract attention from other scholars interested in the history of ancient disease. A key contention is that while the initial theories of what caused the Hittite plague pointed to tularemia, the evidence base for such claims were pretty sketchy. For example, the reported symptoms of a disease do sound like tularemia, but they also sound like other diseases endemic in the region at the time, such as plague. A recent review has also systematically reviewed the evidence available and come to the view that the disease in question might very well be something else entirely, pointing the finger at malaria. I must be honest, remain sceptical of the idea that we might be able to identify a specific incident of biological warfare so deep in the historical thicket, but I do get why folk find this stuff so exciting, and have devoted such effort into trying to piece together a case for the idea of ancient biological warfare. I also think that such work is fascinating, as it seems to point, at the very least, to evidence of embryonic practices and understanding of biological warfare at the edges of prehistory. I would be interested to hear other folks' theories on this, so do send them my way. And finally, something you might also be able to help me with, dear listener, which links back to our last show on poison arrows, as well as the 4 coffees I've already sunk putting this episode together. After doing some very limited research on paleopathology this week, I can't help but think of a scenario in which a guy, we'll call him Doug, is walking around minding his own business on a Tuesday somewhere, about 6,000 years ago. Out of nowhere he gets hit by a small arrow which goes straight into his shin. Angered, confused, but feeling okay, he takes the arrow out and, turning the other cheek, decides to cut his losses and hobbles home. A little later, he feels a little ropey and starts to worry if that arrow had been dipped in something. By next morning, he has left for heaven, and his friends dutifully drop him in a peat bog. It's what he would have wanted. If Doug, forever in our hearts, was found today, when they were excavating the foundations for a new multi-storey car park, is it technically feasible that we could detect evidence of one of those arrow poisons discussed in the first episode still preserved in his bone? I would also be interested to hear folks' theories on this, so do send them my way. You can get hold of me via tweet or email in relation to this, or other stuff related to the show. If you do look for me on Google, I'm Dr. Brett Edwards, the middling academic who works at the University of Bath, not the oh-so-handsome, talented and successful actor who tops the list every time I do a web search for my work office room number. So that's us for today. I hope you enjoyed the show, and I'll see you next time for our antisocial history of poisons and pestilence.